What's up everyone, Patrick here, welcome back. Moving on to the next video, we got to evaluate these three expressions over here. So starting with number one, we got the square root of 27 over the square root of 3. This one's actually pretty simple. What you can do is you can combine both of these under one square root, like that. The reason why is that just in general, if you got root a over root b, something like this, you can combine that into one square root. And actually, in fact, it could be the nth root. Right over here, because we have a square root, there's like an imaginary 2, right there. But this could be also the third root, so you could have like the third root of a over the third root of b. That would be the third root of a over b. Now, in order for this to work, these two have to be the same. So you can't have like the third root of a over, let's say, the square root of b, right? Because that would be like a 2 there. 3 and 2, those are different, so you can't combine it into one like that. So these two have to be the same in order to combine it into one expression like this. And so from here, basically we would have the square root of 9, which would give us 3, like that. Another way actually you could do this is the square root of 27. You could simplify that radical, so that would be like root 9 times root 3, which would give you 3 root 3, right? Root 27 and 3 root 3 are the exact same thing, so if you're dividing by root 3, those cancel out, and you're just left with a 3. So that's another way that you could do it. All right, number 2, 27 to the power of a half times 27 to the power of 1 over 6, all over 27. So this one looks complex, but what's nice is that we're dealing with the same base for all these exponents. There's like an exponent 1 over here. So because we're dealing with the same base, we can just basically do operations on this. These two are multiplying, so we could take the 1/2, we could add the 1 over 6, and then we're dividing here, so we could subtract the 1. And so from here, all you have to do, let me write out this expression on the side here, is get a common denominator, which would be 6, so it'd be 3 over 6 plus 1 over 6 minus 6 over 6, which would give us 4 over 6 minus 6 over 6, negative 2 over 6, negative 1 over 3. So basically all of this here, it simplifies to 27 to the power of negative 1 over 3, which would be like 1 over 27 to the power of 1 over 3, which would give us 1 over 3, right? Third root of 27 is 3. So we took this, brought it down to the denominator to change the exponent to a positive. Third root of 27 is just 3. So 1 over 3 is the final answer for this. And then over here, what we can do is we could do this in different ways. First thing I'm actually going to do is I'm going to take this, because it's a negative exponent, I'm going to bring it down, or bring it down to the denominator, and then it changes to a positive, like that. And then what we could do is we can actually evaluate both of these separately. So we would have 64 to the power of a half to the power of 3, and then this would be 16 to the power of 1 over 4 to the power of 3. Now, 64 to the power of a half, that's 8 to the power of 3, would give us 512. All over, 16 to the power of 1 over 4 is 2, to the power of 3 is 8. And then 512 divided by 8 would give us 64, like that. So that's the final answer to this. Another way you could potentially do this is you can maybe even change this 64 to be 2 to the power of 6. And then you could change the 16 to be 2 to the power of 4. Maybe that would work. So you would end up having 6 times 3 over 2 would give you 9. So you'd have 2 to the power of 9 over, the 4's cancel out here when you multiply, so we'd have 2 to the power of 3. This would end up being 2 to the power of 6, which would also give you 64. So that's another way to go about it. I would probably just go about it this way. But because 64 and 16, they both can be changed to have a base of 2, this is another way to do it. Either way, whichever way you do it, 64 is the final answer.